Okay, sweet. I'm going to demo. This is the first ever semi-public demo of the Filecoin implementation. And I'm going to demo it with the libp2p network visualization tooling. So the goal of this demo is really that network visualization toolkit, but the thing I have it working with is the Filecoin implementation. So I'll walk you through that. Can you see? Is it this? Sim. Can you read this roughly, or do you need it to be bigger? Bigger. Is that good enough? All right. So FilNet Sim, Filecoin Network Simulator and Visualizer. This is a tool to simulate a Filecoin network locally. It spawns Go Filecoin daemons randomly. It issues commands to them via the CLI tool. Then the sim issues actions randomly according to the set of program options. The sim supports connecting to individual Filecoin nodes to issue commands manually, meaning the simulation can be going and you can hook into it and also send commands. The sim consumes all event logs coming out of those daemons and transforms them into input logs for a visualization. So I'll walk through how that works a little bit. I'll give you like a good diagram. I'll kind of show you the demo first, and then I'll walk through how that tool works. The sim also serves, so the visualization is on the web app, so this little tool has a web server. And in the future, this may run across many machines. So the structure of this is set up so that, in theory, we can easily split up this tool and have it be running across a bunch of machines, and then that aggregates into a single web app that shows you a visualization of large-scale networks. So ideally, I would love to see visualizations of DHTs in the thousands or tens of thousands of nodes. Like see like the entire Kademlia like routing table shifting. Now that might be hard, but we can think about how we might do this kind of stuff. So effectively, what this simulator does is there's a program that is going to send a set of actions to these daemons. And the program has a bunch of options. So things like the maximum number of nodes to start, certain timing things, whether or not to send certain actions, some properties around mining. So like this is the consensus forking, and so on. And then this uses Go Filecoin, which is the Filecoin implementation. So here, I'll just do it here. So the Filecoin implementation is a tool much like Go IPFS. Everybody familiar with Go IPFS will recognize some of the things here, like the libp2p swarm command. And it implements a full blockchain in IPLD. So it has a DAG command, just like Go IPFS. So you can pull out all the objects of the Filecoin blockchain through the familiar IPLD commands. And you can walk through the blockchain that way. So you could pull out specific pieces, and we'll see that in a moment. And then as a blockchain, it has a set of transactions. We call those messages. The transaction smart contracts model, same way of thinking about that. You can think of actors and messages and message passing. So we tend to call them messages and actors because of a whole bunch of reasons around thinking about like programming languages and so on. Anyway, we chose to rename it for now. We'll see if that name sticks. And so this, I could kind of walk you through initializing a daemon manually and so on, but it's pretty involved, and it's much easier to just show the simulator, and then I'll hook into one of the nodes, and then I'll run some commands. So what I'll do first is I'll run this tool with kind of like the basic parameters. And so what this is doing is now it first gave me some links. So it gives me a logging endpoint, and so this is effectively the same kind of log output that that both any kind of libp2p implementation and Go IPFS share, where it's just a bunch of JSON logs. But these are transformed. I'll get into that later as to how that transformation happens, but they're not the raw logs that are coming out of Go Filecoin. They have been changed by the simulator tool. I'll get into why when I explain how this tool works. So then it also offers a couple of like endpoints for some visualizations that I have mounted onto this. Then there's a whole bunch of options here. These will be set by the flags. And then here it's just starting to add daemons. And it gives me a few of the options. It shows me the repo of where that particular node is. It gives me the wallet address for that node. This happens to be a miner, so it has a miner actor address. It gives me a command prepped up to like connect to it if I wanted to. And it gives me a command prepped up to it if I wanted to use it, right? So I can connect to this one, and I can say, hey, what's your ID, right? Can do it over here too. Let's see. Whoops. I can do swarm peers, and typical kind of stuff. This says IPFS should not. That should say P2P. That's like a libp2p thing. We'll fix that. But it also can do things like show me the order book, and so I can see like the asks, and so that's like a set of orders that are now in the market. And so this has been running for a little bit of time, and so like it already generated a whole order book. We'll see it in a moment. And over here, I just have htop running, so there's a whole bunch of daemons being, just so that you get a sense, it's filtering on the word Filecoin, and so that means there's a bunch of daemons running and a bunch of commands being issued. And so that's just to show that the simulator here is creating a bunch of processes that are running. Now, I'm going to kill it and restart it, because we really want to hook into the visualization at the beginning. Otherwise, JavaScript, D3 kind of blows up. It's kind of funny, but... So I'll start it up again. Oh, actually, before that, all the daemons should die. If they... Are they not dying? I guess they're all dead. Maybe htop is like... No, there we go. Here, I'll restart htop. So now, we'll run it again, and we'll open the visualization. So this is what that is doing. You can't see it. I can barely see it. So each one of those things is an action. So that's a payment transaction. That's a deal happening. That's a block being mined. There's a node entering. There's another payment transaction. Another node being another block being mined. More payments and so on. And here you can see all the bids and asks that miners and clients are adding to the market. Here you can see a depth chart of the storage market. Here you can see the heads of the, this is the blockchain effectively as it's growing. And here on the right is the deals being tallied up. So these are bids and asks are, when this happens and they overlap, then these are candidates for a deal. And the simulator will notice that, and then it will tell those two nodes to make. Well, it'll pick some of those nodes and have them make a deal, and it'll show up here. And when a deal happens, then actually files are exchanged. And so I'll show you that in a. So to show that, I can go back here and ask to see the deals. Order book, deals, JQ. I can grab one of those things. And I then can ask client cat that hash into file. Now I can open file. I don't know what it is. Oh, I think this is an encrypted one. I'll grab another one. Same story. Don't remember the keyboard shortcut. This is, I think, the README. Oh man, I gotta get a better one. Yeah, there are cat pictures here. Yeah, I really just need to increase the probability of sampling cat by making it all. Oh man, none of them. Anyway, so this is transferring real files, and they're being pulled from a set of set of test files that I have. But that means that these nodes are actually adding and transferring real files. Like clients are sending their real files to the miners and having them stored. So that's so the whole idea of the storage market is working where clients are putting bids, miners are putting asks, they get matched into a deal, then once there's a deal, the client sends a file to the miner to store, and that's what you saw. So we don't have the equivalent of the retrieval market here shown, but it would be kind of the symmetric set of operations. And down here you can see kind of the set of heartbeats. And so here, if you look kind of closely, it's a little bit hard to see, but you see that all of these chain heads switch and converge because that's consensus happening. So and this so far has processed about 6,700 events. At some point it gets to be too much, so I need to reboot the simulator because this is running 15 different Falcon nodes in my machine. Oh, one more thing. If I click one of these things, I land on a Falcon Explorer, which is effectively kind of like a blockchain explorer tool, but it's built right in. And so this is following the chain as it appears. I can click into it and see this is a particular block. This is the miner. This is the state root. The state root is the root of the state of that block, and so that means all the state transitions have been applied. That's all IPLD, so you could browse it. Right now, for example, Ethereum, we have all of the IPLD importers for Ethereum, so we can do the same thing in Ethereum as well. And here is a set of messages. So these are the actual transactions, and you can see the method invocation that's happening and the parameters that are being sent there. So in this particular block, we see that we have the ones that don't have a method is just sending money. So that's just a normal transaction as you would on Bitcoin. A payment, here's adding an ask, another payment, and so on. There are no deals on this one. And these are kind of the outputs of each of the messages. We can also see the set of actors. So this is looking at the local storage of the chain in a sense, and we can see each one of these actors think of it as a smart contract. It has an address. It has the SCID of the code that is executing this actor. It has memory, this memory is just the local storage of the actor or smart contract. And here are the functions that it's exporting that you can call. Here you see these are Go types. Those will not be Go types in the future. And there's a bunch of different kinds of accounts. For example, instantiate one of these actors for you and maintain a set of local state. So and this explorer is we clicked on a particular node. If the network was divided, and we clicked on a different one, then we would see potentially different state. So the idea of this visualization is that it sets it up so that you could explore the network in the right direction. Now, the explorer is connecting directly to the node and asking for things, and it might in the future also write. This visualization, though, is meant to be read-only, or at least to have a read-only mode where it works entirely off the logs. And the idea for that is that we should be able to take a trace of a previous run and store it, and then just from the logs be able to replay the entire thing to see it. And ideally later on, maybe potentially have some playback controls, so we could actually speed it up or slow it down or jump to a specific point. And the idea of that is that it could help significantly with debugging. So right now this seems super chaotic because there's a lot going on, but we can play with this, and instead of doing all this stuff, we can turn off a bunch of the things that it's doing and say maybe do no automatic actions, and then actually manually script what I want it to do. Actually just right now I want to connect to, so it's a lot like IPTV in a sense, but it's basically the instrumentation of IPTV plus some specific simulation actions specific to this particular application, plus some of the event translation. So the event translation I mentioned that I was going to go into, that's because the event logs that are coming out of the node are specific to how the Go Falcon implementation works. And so that's, the event logs there are like whatever the developers want to get out of those logs. Now that may not be what the visualization wants. And so that translation is there to make it easy for each group of developers to focus on what they care about. So the Go Filecoin developers can just think of the events that they want to put into the Go Filecoin node, and the visualization developers can think about the events that they want to visualize, right? So things like sending a payment, things like making a deal, and so on. There might be a one-to-one correspondence. Some event in there might be exactly what they're looking for, but maybe the parameters that they're looking for are different. Maybe the whole event log output is too much, maybe we don't need all of that, or maybe it's actually missing something and you need to aggregate multiple events into one. So that translator in the middle is a very important piece that makes it easy to build visualizations on top of just the raw event logs by just putting the intelligence of the visualization into that translation, in a sense. And so I think that structure is really promising for libp2p in general, because it could work equally well for the DHT. We could come up with a DHT visualization that's similar to this, where around the ring we just have DHT nodes, and what we see is like puts and gets and retrieval. So it's puts and gets onto the DHT, and we can see these would be kind of like actual like requests going through. Or ideally, we could also draw the connections between these nodes and see the buckets, right? So that's where kind of this is headed. Now, of course, the DHT that's massive, we would have to think about how to visualize that. But there are like really good visualizations for this kind of stuff. Like we do know how to take huge amounts of data. And if this is what I'm, no, not this, oh man. I won't look for this, but there are ways of visualizing huge amounts of data well, and so we could totally do this. We could totally write visualizations that help us debug, that help us understand protocols. By the way, education is a whole other thing here, where we could script this to go follow a potentially user input and tell somebody, like teach somebody about a protocol by carefully scripting the events and waiting for user input before moving between them. And so you could explain how a DHT works through this interactive thing just written on top of a normal event trace of the protocol. You could just craft that event trace by just writing the event log yourself. Like maybe you record something and then you tune it a little bit for the right pedagogical effect, right? Like maybe you reduce the amount of events that are happening. Maybe you pick a specific interesting edge case to just demonstrate something. So that's the kind of potential of tools like this. And what I want to go with it, where I want to go with this is make this general enough to the point where writing a visualization for a specific protocol could be mounted on top of like this very general tool that does all of the event aggregation and the option setting and like all of the heavy lifting of the orchestration. So it'd be some kind of like modular plugin thing. But that's kind of where this is headed. And just to show you, this other visualization is here. I'll show you like a different. I can run the simulator again and look at the different at the blockchain visualization. And what that does is it shows me the chain. So this is the same exact thing. It's just a different front end that's looking at different events. And the events that I'm interested in here are just the block announcements from each node. So whenever a node sees a block, it emits an event. And whenever a node picks a block as its head of the chain, it also emits an event. And so what I'm doing here is I'm just graphing, and by me I mean Nicola. Nicola wrote this, so won't take credit for that. He's adding, whenever he sees a new block, he adds it to the graph. And then whenever he sees an additional event of having seen that block, he just logs it as a count. So the dark number here that we see in the bottom is how many nodes have seen that block. And the blue number is how many nodes are using that block as the head of the chain. And so we can see right away like whether or not we're achieving consensus. And this is kind of going fast, but like this is not forking. these things are converging and staying. So here I set up parameters specifically to try and cause it to fork, with 2 or 3 blocks per round, just to show what happens when like multiple parties like try to mine there, and then whether or not we get convergence or a fork, and they're still converging here. Now, of course, this is all local and like not realistic setting and so on, but it gives you an idea of how we might use tools like this to debug consensus protocols and to understand whether or not they're converging, or to understand if like perhaps some important event there is like getting lost. I found a bug through this. I found a bug that one of the events is not being emitted by at least one of the nodes, and I think it's the node that generated the block. Not 100% sure, but if you look at the counts, they don't match up. Like there's always one less. So anyway, it right away like found something like that. So this is just a different front end, and you could totally imagine generating a bunch of different front ends for a protocol. So I'd love to see kind of maybe IPFS like a bit swap front end to see kind of like your bit swap peers and how much bandwidth you've sent them, like what the want list is. So you start doing a bunch these very focused applications just on that protocol and mount it just on top of the exact same event trace, right? Any questions so far? That was a sim. I set the block time to 3 seconds. No, that was way too fast for, I should have said that. Way too fast for a normal worldwide work consensus. We possibly could get it to be pretty fast, but we would need to start doing some of the clever, like running to many chains kind of at many heads of the chain at once, and then finding ways of aggregating them over time. That's how you can scale throughput. There's all sorts of like sharding techniques that can get there. Ghost is pretty impressive. Like the Ghost paper claims you can get to 1 or 2 second latency or something like that, which I don't think anybody's deployed seriously yet in a blockchain. Other questions?
Is that currently using IPTV, or is that something similar?
It is not currently using IPTV. It should. It was just kind of like a historical reason why I didn't start it with that, but it totally should be rebased on top of IPTV. All right, sounds good. Thank you.